All right, let's jump into this. We are coming to the end of the chapter. Just know that we really only have one more section left, and then we're going to be done with this chapter in this unit on inequalities. So this first part says Kendrick is selling X number of candy bars and Y number of sodas. He's selling at most 50 items. He sells candy bars for $2 each and sodas for $1.50 each. He needs to make at least $75. So the first thing that students looked at was Part A, and A says, can a situation be modeled by a single inequality or do you need a system? I had one student who actually used that right inequality and just tried to throw another inequality on the left-hand side and said less than or equal to 50. The major issue here is that the 75 is talking about dollars and the 50 is talking about items. So you can't really go over and make a single inequality that has all of that information in there. We do have these two different inequalities. B said write the inequalities that represent the situation, and you had the number of X plus Y, number of candy bars and sodas has to be less than or equal to 50, and the next one had to do with the total amount of money, and that is going to be greater than or equal to 75. What we did then was we graphed this. So the students in class, for the most part, used different colors. So they graphed the first inequality, which was X plus Y is less than or equal to 50. And probably the easiest way to do this would be using your X and Y intercepts. So you had an X and Y intercept both of 50. And then you could make your solid line. Once you had that, you could see that is the line that goes from 50 to 50. It is solid. When you try 0, 0, you find out that 0, 0 is a solution and it should be shaded in that direction. So that means that all of the points going from the line towards 0, 0 are going to be solutions for that inequality. The next one is 2x plus 1.5y is greater than or equal to 150. When you graph this using your x and y intercepts, you have an or a y-intercept of 50 and an x-intercept of, I have to check that out. I think it was like 30, hang on, 75 divided by 1.5. That is, sorry, 75 divided by, that's 37.5. Should have been able to do that in my head. So you get to 37.5. That dot looks like it's off just a little bit, but it's supposed to be at 37.5. When you have that, it is going to be a solid line, and you would end up trying 0, 0, finding out 0, 0 does not work, so you shade in the other direction. Now we have some parts that are shaded once, and we have some parts that are double shaded, and we had to make sense of what this meant. So part D says, give a combination that results in at least 75 bucks, but is over 50 items. Well, an easy one would be, you can see that the point 50-50, meaning 50 candy bars and 50 sodas, is definitely going to get you at least $75 because it's shaded by that inequality, but 50 of each is going to give you 100 items, and you're supposed to only have 50. The next one give a combination that results in at most 50 items, but does not get you your $75, 10 sodas and 10 candies. That is going to get you at most 50 items, but it is not going to get you $75. And then you have the things that are double shaded. Give me an example of a combination that meets both of these requirements. If you take a look at 40 candy bars and 5 sodas, that is going to be double shaded, which means it is a solution to both of those. That is going to be a solution to having at most 50 candy bars and getting at least $75. Now, this was a conceptual thing that students needed to look into. It says, what did it mean if you had parallel lines when you're trying to solve a system of linear equations by graphing? Well, parallel lines meant that there was no intersection and no solution. And the question was, does that mean the same exact thing if you had parallel inequalities, if the line aspect was parallel? So we had a few different versions here. We were trying to figure out, depending on which way it was shading, what would be the double overlap, if anything. So you can see on the first one, if they're shading towards one another, you have that strip of solutions to the system of linear inequalities. If both of them are going in the same direction, you can see where I'm pointing towards the part that is double shaded. I used arrows to talk about the direction that I was shading. So those would be the solution to the system. Anything shaded once would only be a solution to one of them. Not shaded at all would be not a solution to any of them. And double shaded would be a solution to both. And then the next one, if those are shaded in opposite directions, there is no overlap. So in that case, the system of linear inequalities would not have any solutions, no points that would make both of the inequalities true. So the original question was, do parallel lines mean no solutions for linear inequalities? And the answer is sometimes, but a lot of times no. The next problem is talking about Finn receives 2 points for true or false questions. He answers correctly and 4 points for short answer. He needs to score, and I changed it to be more than just to get a little bit of variation in here. More than 80 points, and 10 of the short answer questions are mandatory, so you have to do at least 10 of those. X is going to be the number of true or false. Y is going to be the number of short answer. And how can we get more than 80 points? Well, you do have your two linear inequalities. You have the one that talks about total points and the one that is talking about the fact that you need to have at least 10 short answers, and short answers are Y's. So you have those two inequalities. You can see how I use kind of arrows to figure out what direction I'm going to go in. I get kind of too messy when I try to actually do my shading. So my arrows, you can see there is 4 different sections here. One of the sections only one arrow is pointing to, the other one only one arrow is pointing to, one has no arrows pointing to it, and then we have the double arrows. So all of the ones that would be true solutions, and this is assuming that there's infinitely many problems, anything is double shaded would be a solution to the system. An example would be if you look at 2015, that is double shaded, that would be a solution to the system. Anything that was shaded only once would either be just over 10 short answer ones, or saying that you have over 80 points, but you have to be double shaded for it to be a solution to the whole system. Now, one important thing to know here is that when we were solving by graphing before, the actual intersection of the two lines was the most important thing. And on here, the intersection of the shading is the most important. That's why I'm okay going over and graphing using X and Y intercepts rather than slope intercept form, because it's more about looking at the shading than it is about looking at the actual intersection of the borders. After that, we went over and graphed some of these. Since these are small graphs, most of them I did get into slope intercept form. So when you get in your slope intercept form, you graph the border, you test a point, usually 0, 0, to see if you should shade towards 0, 0 if it is a solution, or shade away if it is not a solution. And then you're looking for the place that is an overlap of shading. I use arrows just to keep things neat. I understand that can be a little confusing because you can't actually see things that are shaded only once. But you can see the parts that only one arrow is pointing to. But on this last one, you end up having things shaded in opposite directions, which means there is no overlap and there is no points that are going to be solutions to both of the inequalities. Now let's jump into the homework. The homework says, is it going to be shaded once, twice, or not at all? That's basically a different way of saying, is it a solution to 1, 2, or neither of the inequalities? So all we had to do was test it. And we were testing the point 513. You find out that 513 does make the first one true, but not the second. So it would only be that would only be shaded once, and it would not be one of the points that is the solution to the system, just the solution to one of the inequalities. The next one, we're talking about those keto snacks again. You end up getting 4 calories from protein and 9 calories from fat. It says that X is going to be number of grams of protein, Y is going to be the grams of fat. And it says, I changed it up to say more than, just to get some variation, but more than 150 calories. She must also have at least 10 grams of protein, or the snack will have a strange consistency. So what are the two linear inequalities? It's going to be 4x plus 9y is greater than 150, and x has to be greater than or equal to 10. And you can see how I use my arrows here just to keep things a little bit neater. Anything that is shaded once will only be a solution to one inequality, and the things that are in the overlap are going to be a solution to both of them, also known as the system. You could also have 3 inequalities or 4 inequalities to kind of shade off a full section. We're going to be talking about that a little bit later. But for today, just 2 inequalities. On here, this was just seeing if you guys could do basic ones that didn't really have way too much meaning behind them. On that first one, you did not have to switch your sign because you were getting in a slope intercept form and never divided by a negative, and that ends up getting you negative 3/4 x minus 3, and then negative 3/4 x plus 5. When you look at the inequality aspect of this, they are going to be shaded towards one another, and you have that strip down the middle. that is going to be double shaded, and everything else would only be single shaded. On the second one, you end up having two different things that you are going to be graphing. One has a solid line. Make sure that you are checking to see if you have solid versus dotted. As I was making my key, I was kind of changing the problem. So yours on that bottom one should say less than or equal to, meaning it's a solid line. Just wanted to get some variation here. Anything that is not shaded at all is not going to be a solution to either of the inequalities. If it is shaded once, it's a solution of one of them. And if it's shaded twice, it's a solution to both of them. The next one says, write another linear inequality that if put in a system with the following would result in no solutions. Well, for it to be no solutions, you're going to need to have that parallel border. So you can see this one has a y-intercept of 1 and a slope of 1/2. So it's going to be, theirs is going to be y is greater than 1/2 x plus 1. So what I said was that yours had to be less than or equal to. So the border is either going to be dotted or solid. You're still going to want to have that 1/2 x so that the borders are parallel. And the y-intercept is just going to be anything that is going to be under 1. As long as it's under 1, then you are going to have no solution. I guess technically also it could be the number 1. And the reason for that would be that they would be on top of one another. One would be solid and one would be dotted. And the dotted means those are not solutions. The solid means they are, so there wouldn't be any overlap. So technically, most of you guys are probably going to say any number under 1, or you're going to give me a number that's under 1. But if you did do 1, then 1 would be another one that would be no solutions because you would have nothing that was a solution to both of your inequalities because this is dotted. So, all right, thanks for watching.